Hi guys. So what we're going to do here is this is actually a piece of information that we usually do first semester. But this year we decided to wait because it's one of those characteristics that we would have talked about the very first day when we did all of those characteristics. But we waited because it really doesn't come up until this polynomials unit. Well, now that we're in the polynomials unit, I want to make sure we go ahead and talk about it. So what we're going to talk about are mins and maxes. Now, we've already talked about a specific type of min or max called the global or absolute min or max. So those two words can be used interchangeably. And that is the highest or lowest point on the entire function. You saw these on quadratics and you saw them on absolute value. Okay, it's the absolute highest or lowest point on the entire graph. But what we're also going to talk about now today is something called a relative min or max. So a relative min or max, okay, the relative min or max now has the text showing that I wanted to show. So a relative min or max is also sometimes referred to as a local min or max. Those two words are used interchangeably. And what they are is they're not necessarily the highest point or lowest point on the entire graph. Now they could be, but really what they are is the lowest or highest point relative to the other points around it. We sometimes refer to these as turning points on our graph. So what I mean by those turning points, if you look at this first function here, okay, this graph has a couple of turns in it. The turns are where your graph changes from increasing to decreasing. So I'm going to go ahead and highlight where those turns are. There's a turn here, here, and here. Each of those turning points, although it may not be the highest or lowest point on the entire graph, is the highest or lowest point relative to the points around it. So each of those points is what we call a relative extrema. Specifically, we can identify each of those as either a relative or local, again, use either word, max or min. So this first point right here, that is the global minimum or the absolute minimum of the graph. It also is a local or relative minimum on the graph because it's the highest or it's the lowest point relative to those points around it. The other 2 points, they are not the highest or lowest on the graph, but they are still those relative mins and maxes. So this point here is a relative maximum because it's a relative max to the points closest to it. This point here, the bottom of that curve, that is a relative minimum. Okay, you also, again, those words are used interchangeably. You also could call that a local minimum. All right, looking at this graph here. All right, so on that graph, we have a couple things. We do not have an absolute max or min. We do have some turns. I have a turning point here and here. In the middle, that section right there, that's the most commonly missed spot. That is not a local min or max. What that is actually is a point of inflection, which is what we just did last class when we talked about cubic functions. So in all those cubic functions that we looked at last class with transformations, none of those had relative mins or maxes. Okay, they did not have any turns. Those turns are where your graph changes from increasing to decreasing. Okay, so this graph changes, it's increasing until this point. Then it's decreasing until that point. Then it's increasing after that point. So this graph only has 2 turning points. It only has 2 relative or local mins or maxes. So this point here is a local maximum. This point here is a local minimum. Now, similar to mins and maxes, we want to pay attention to what our question's asking for. The actual value of that maximum or minimum is the y-coordinate. Okay, where it's located is your x-coordinate. All right, now let's look at this last one. So this last one, let's talk about a couple things. First of all, we do have an absolute or global maximum. That is the highest point on the entire graph. That point, though, is not a local maximum because we don't have anything to compare it to on the right side. So this endpoint over here, okay, is nothing. It's not a min or a max in any way. We can't say it's local because there's nothing to compare it to over here on the left side, and it's not the lowest point on the entire graph. So what this graph does have is a local or relative maximum. And then this point here is both a local and a global minimum on my graph. All right, so for a quick practice, I'm going to go ahead and just sketch a graph here for you guys. So let's make this graph look like this. Oh, my Apple Pencil cut out. Let me redraw that. There we go. Okay, so I'm going to label, a few points here. So this is A, B, C, and D. So what I want you guys to do on the Edpuzzle, question is going to pop up, and you are just going to enter what each of those points are. Is it a relative or local, global, min, max, etc.?